Let's say that this box contains the population of something, and it is impossible for us to gather information about the total population. So in this case, we can take samples from the population and acquire data from the samples to make inferences or predictions about the population. And we're going to take 5 samples of 30 from this population. And these samples are taken with replacement. So we have sample 1, and it has its own mean, x bar 1, and its own standard deviation, sigma x bar 1. Next we have sample 2 with x bar 2 and sigma x bar 2. And we continue this till we have our 5 samples, and as you see, since we have a replacement, we have some overlapping areas for some of the samples. Now to the central limit theorem, which basically states 3 things. And we'll go over these in depth in a minute. Number 1 is that if the population the samples were taken from has a normal distribution, the sample means together will also have a normal distribution. Or if the population is not normally distributed, but the sample size is greater than or equal to 30, the distribution of the sample means will approximate a normal distribution. Number 2 is that this distribution of the sample means will have a mean that will be equal to the mean of the population. So mu of the x bars equals mu of the population. And number 3 is that the standard deviation of this distribution of sample means will be equal to the population standard deviation divided by the square root of n, with n being the sample size. And this is called the standard error of the mean. Okay, so let's go through an example of this. Let's say that there's a population that consists of the values 1, 5, 9, and 13. The mean for this population is 7, and the standard deviation is 4.472. If we randomly choose 2 of the values from our population with replacement, there are 16 possible samples of 2 from the population, which I've listed in this table. And we can calculate the means for each of the samples, x bar 1 through x bar 16, as you see here. From the sample means, we can create a frequency table and a probability distribution, which I've done here. And a probability histogram from the sample means looks like this. As you can see, it's evenly distributed around the mean, or bell-shaped, which is what the central limit theorem stated. Next, we can calculate the mean of the sample means. Add up all of the sample means, x bar 1 through x bar 16, and divide by 16, and we get 7. Same mean as the population mean, which is what the central limit theorem stated. Next, we can calculate the standard deviation of the sample means, which if you calculate it out, equals 3.162. And the central limit theorem stated that the standard deviation of the sample means is equal to the population standard deviation divided by the square root of n, with n being the sample size. If we check this, we have the standard deviation of the sample means equals 4.472 divided by the square root of 2, our sample size, which equals 3.162, the same we calculated above. Alright my friends, that be the basics on the central limit theorem. Hopefully this video helped you out. I do have more videos right there for you. Till next time, I am out of here.